Hi, I'm Philip Reeder, the Dean of the Baer School of Natural and Environmental Sciences, and today we are at the Undergraduate Research Symposium at Duquesne University. And what this is, it's a program that involves students who are in their freshman, sophomore, and junior years, and allows them to get in-lab, on-site real experience working in a research laboratory, working on real-world projects along with faculty mentors, graduate students, and that's what makes Duquesne really a unique place.
So I work with Dr. Madera, and the research is related to drug addiction. And focusing more on drug addiction, it would be these transporters that are responsible for taking in excess monoamines that formulate in the synaptic cleft and are responsible for modulating that concentration. Essentially, these things are what make you happy, what make you sad. They regulate mood and behavior.
And I've been looking at saturated absorption spectroscopy of potassium-39 vapor. And the goal of why I'm using that is we're going to try and get these atoms down to nanokelvin temperatures in order to look at material interfaces of them. So this is one of those, this is a step in obtaining those almost near absolute zero temperatures that we're hoping to gain.
Obviously, people are having implants at every second in every hospital, hip replacements, knee replacements, spinal rods, and so these metals go in your body. When it corrodes in your body, it can either become carcinogenic or allergenic, and sometimes the bone has difficulty binding to the metal, which causes the implant to fail. And obviously you don't want any of those things to happen. So in my lab, what we do is we work with different types of molecules and different types of chemicals and try to find a way to modify these implant materials so that they are healthier.
My project for the 2014 summer undergraduate research program was to validate a waterborne hormone assay using salamanders. This method would allow us to get a hormone reading from the animal without euthanizing it.
Pretty much everything that I did was really neat. Working with lasers is a lot of fun, actually the laser that I'm using isn't in the visible spectrum, so I got to use some different techniques to make sure I was able to see the laser. We have a camera that's hooked up that will see the fluorescing of the atoms once the laser's in resonance, so that was really cool to see that science.
Learned a multitude of stuff as far as the biophysics, something that I was not even used to even thinking or fathoming about, but being able to express how cells develop and move, and being able to express that in a physical sense was something that was very much new to me and opened my mind to different possibilities.
I didn't think I would like research all that much, but I absolutely love it more than I would have ever guessed. And I think one of the reasons that I do love it so much is because I have something to show for it at these symposiums.
The symposium this year was great. I've learned so much. I was only a freshman. I'm only going to be a sophomore, so I didn't have a ton of science class experience or lab experience. So this summer I've learned so much just about the scientific process and lab techniques in general. It was really a great experience, and I met a ton of great people, so it was awesome.